All right, this is Mr. Wyrick, and I'm here today to kind of go through these notes over parallel and perpendicular lines with you. I'm not here today, I'm out at a tennis meet. You have these notes, you can click through either as you're listening to this video, like kind of split screen, or you can just wait and you can do one of the things at a time. So slopes of parallel and perpendicular lines. First off, if you're gonna find parallel slopes, all you need to do is find the slope for whatever it is that you're doing, however you need to do that. You can count on the graph, you can do the change in y over change in x if they just give you a couple of points, but you find that slope, and then any slope that's gonna be parallel to that one is exactly the same. So they're going to ask you today on the Edgenuity quiz to find the slope of a couple of points and then say, what would be a line that would be parallel to this line? What's gonna be a slope that would be parallel to this? So if you identify the correct slope, then the parallel slope is going to be exactly the same, same change in y over change in x, okay? So our next slide is perpendicular slopes. Again, the first step when you're finding a perpendicular slope is to find whatever slope it is by either counting on the graph, change in y over change in x, or you're comparing the points and you're doing the change in y first, the change in x for the bottom, and you put those up, you find that slope. Perpendicular slopes are opposite reciprocals of one another. They multiply together to make -1. The easiest way to remember it, and I've put a picture of Missy Elliott on here because of the song, is it worth it? Let me work it. So you put your slope down, flip it, and reverse it. So you're gonna take whatever fraction it is, flip that fraction upside down, and then reverse it by putting a negative sign in front of it. That will give you the opposite reciprocal slope. That will give you a perpendicular line, one that will meet at a 90-degree angle. You can always test how they look in Desmos. It's a great place to check and see if it looks like it's gonna be 90 degrees. I did put some examples on here. If we have a -1/2, a +2, I take that 1 over 2, I flip it, so it's 2 over 1, and I take away the negative. Now it's the opposite reciprocal. A -4/5 and 5/4. So again, I took that -4/5, I flipped it, so it's 5 over 4 now, and it was negative, so I took that minus away, it's a +5/4. So a -4/5 and a +5/4. And then I also listed a pair, 0 and undefined. If you have a slope of 0, remember that's flat, that's a horizontal line. If you have an undefined slope, that one is straight up and down. So those will obviously form a 90-degree angle. Don't forget, put your slope down, flip it, and reverse it. That's gonna be a real easy way for you to remember to do perpendicular slopes. The slope formula is here. I'm not a big fan of this one, but it is important to understand that the formula does apply. Again, it shows you the change in y over the change in x. It just does it in a very specific manner. It talks about y2 and x2. That is your second point on your graph. And then y1 and x1, that is your first point on your graph. So you take the one that is further to the right and subtract the one that is further to the left. I always like to think of it again as delta y over delta x, the change in y over the change in x, so that we can just find each one of these and move forward. But if you are given variables at any point, it's important to remember this formula. Oh, skip the slide. So, yeah, just go back. Maybe it doesn't want to go back. Go back. So how can we prove that these are parallel using the slope formula? There's a question like this that's going to show up on some of your quizzes, not everybody's, because it does random questions. And on this one, it would be the second y value minus the first y value, so z minus v, and that would be over the second x value minus the first one, that's x minus w. So we have z minus v over x minus w. If we put this next one together, we have z plus b minus b plus b, because we've gone up the exact same amount each time. If we combine those, the b's will actually subtract from one another and end up canceling out. They will go away, so we have z minus v as that slope. Basically, it's saying if we put numbers in here, the way the subtraction goes, like this one would be like a negative, I don't know, -6 minus 1 for a -7. This would be like a -1 minus 6 for also a -7. It's saying that the subtraction is going to work out the same way, even though we have altered those numbers. Same thing with the x value for the bottom. We have x minus w on the bottom, and this would be x plus a minus w plus a. Again, that x value has not really changed except for maybe a little bit. So it's like saying 5 minus -3 is the same as 4 minus -4. Okay, it's gonna, both of them add up to 8 so that we get the exact same slope. All right, hopefully that made sense. The a's would kind of go away. We'd end up with x minus w on the bottom for both of them. Just make sure you put it in the formula correctly. I'll be demonstrating something using graspable math during class, so if you want to check the Zoom on that one well, I'll just see if I can figure out a way to get that to you. The other tricky question, how do we prove that these lines are perpendicular with the formula? So this would be C minus A on the bottom and a -D minus -B. Oh no, wait, the y values go on the top. C minus A on the top, -D minus B, or -D plus B on the bottom, and the other ones would be the second y, so B minus D on the top of the other, and then A minus C on the bottom. So when you get them all put together, it should look like, especially when we flip this one, the -D minus -B is going to be -D plus B, which would be the same as B minus D, and we have B minus D on the other one as the top. So the formula gets flipped, and one of them is going to be negative as compared to the positive that was on the other. So that's going to leave us with perpendicular lines. Again, you put your slope down, you flip it, you reverse it. This is just one of the questions that shows up on the quiz that's going to be pretty weird. You have to make sure that when they multiply together, they would multiply together to make -1, because that's how we can tell they are opposite reciprocals. Hopefully this helps you out. If you have any questions, just save them for when I come back. Remember, Wednesday is going to be the PSAT, but 8th period, everyone should be done testing, and you guys should be back in class so you can ask me any questions that you got stuck on. Thanks, guys.